Fermium-257 is a radioactive substance whose decay rate can be modelled by the formula P is equal to P0 e to the kT, where P is the mass in grams and T is measured in days. P0 is the original amount and K is a constant. The time taken to decay to half of the original amount is known as the half-life. The half-life of Fermium-257 is 100.5 days. Determine the value of K to three significant figures. Well, if the original amount is P0, we're looking at when it gets to a half P0. So that is going to give us that. And the P0s will cancel here. So we're after e to the kT equals a half, where t is 100.5. So what we want to do is solve e to the 100.5k is equal to 0.5, and we're just going to put that in the cas, and it gives us that k is negative 0.00690. How many days will it take for 100 grams of the substance to first decay below 5 grams? So they're giving us a P0 value here. So we're going to have 5 is equal to 100 e to the negative 0.00690 times t. And again, we're going to solve that on the cas. And that will give us t is approximately 434 days. Determine the rate of change of the amount of fermium on the day found in part B. So we have P is equal to 100 e to the negative 0.00690t. And that means dp dt, and you could do this on the class pad or use the chain rule, is going to be negative 0.6897. I'm using a slightly more accurate figure, so it is 100 times this, but it's 100 times the value that was on my calculator. E to the negative 0.00690t. And then we want dp dt given t equals 434, and I may have used a slightly more accurate figure for that in the calculation as well, but I gave the calculation to 3 decimal places as 0.034, so negative 0.034 grams per day.